proportion, let me just quickly remind you of the direct proportion. Direct proportion, if you have the relationship between y and x, y over x is equal constant. This constant, we call it constant of proportionality, or y equals k times x. Example, if x or y, let's say, y equals 5 and x equals 10. So first of all, we find, and I'm telling you that there is a direct proportion. So there is a direct proportion between x and y. So the first thing you do is just you find the k, then you can tell me k is 5 over 10, which is half, right? So now we know that the relation between y and x is something like this. You divide y over x, you get half all the time. So if I give you, for example, if I tell you that, okay, if x equals 20, what is the value of y? Then you can just plug this in. You can tell me, okay, y over 20 equals half. So y equals 20 times half, which is 10. Right? So if y 5, x 10, if y, for example, 10, y is 20, so it's clear that if one of them, for example, doubles, the other one doubles. If one of them, becomes half, the other one becomes half. So it's a direct proportion. The second type that we covered, which is the inverse. The inverse proportion. The inverse proportion, we say that x times y equals k. Or you can say x equals k over y. Or y equals k over x. Okay? Example. Suppose I'm telling you that there is an inverse proportion between y and x. I'm telling you this. There is an inverse proportion. So first of all, what you do is finding the k, the constant of proportionality, which is 8 in this case. So the relation becomes like this. All the time, when you multiply x and y, you get 8. So if I tell you that, okay, what if x equals 4? What is y? You just tell me y is 2. When x was 2, y becomes 4. When x becomes 4, y becomes 2. So if one doubles, the other one becomes half, or something like this. This is the inverse relationship, okay? So that takes me to this problem. The ideal gas law relates the pressure P, temperature T, okay, volume V of an ideal gas. The law states that PV is equal to nRT. Well, let me write this here. This is 7.7. PV equals nRT. T is temperature, P is pressure, V is volume, R is universal gas constant. So R is constant. This is important. So we know which one is variable, which one is constant, okay? And N is a measure of the number of the, this is a difficult word for me. Well, anyway, molecules of gas present. It's just a number, okay? It's just a number. So for the following questions, assume that N remains constant. Again, N is constant. So this is very important. This guy is constant. This is R here, right? And this guy is constant. So N, R, both are constants. Okay? They are playing the role of the K, actually. Okay. If the temperature, no, let's answer question A. If the temperature of an ideal gas remain constant, how are the pressure and the volume of the gas related? So the goal is to check the pressure versus the volume. What is the relationship between the pressure and the volume, given that the T, the temperature is constant, doesn't change, okay? It's like the constant of proportionality, the K, okay? So this is P, let's write this. PV equals nRT. Okay, the best way to get the relationship is to write the constants, all of them, to put the constant in one of the sides and keep other stuff in the other side, okay? So in this case now, what do we have? This is constant, this is constant, this is constant. You multiply all of these guys, you get a constant. So what do we have? You have P times V. Can you hear me?
Yeah.
Okay.
Yeah, we can hear you.
Okay, P times V is equal constant. So P times V equals constant. Whatever, if you'd like to multiply them and get a number, let's call it, I don't know, K if you'd like.
Excuse me?
Yes.
I think someone's in the waiting room.
Let me check. Yes, Jacob. So we got PV equals constant, K. So when you have something like this, what kind of relation we have? Is it inverse or direct?
Inverse.
Thanks, Jerry. It's an inverse. Please, this lesson is important. It's not easy, I believe. And the main two things I started with, you need to keep them in your mind. Let me repeat here. This is the first one. Direct relation, proportion. This is the second one, inverse of proportion. Okay? So keep these in your mind. So it's an inverse proportion. It's an inverse proportion. For B now. Let's go for B. Let me copy again the relation. You have PV equals nRT. For B, it says if the volume remains constant, so the volume is constant, we need to investigate the relation between what? The pressure and the temperature. So again, the best way to discover the relation, to investigate, is to write the constant in one side and everything in the other side. So what do we have? We have this guy. Where is it? The volume is constant. This guy is constant, and this guy is constant. So I'm going to divide both sides by V, right? So I'm going to get P over T equals NR over V. I divided by V and I divided by T because I would like to check the relation between pressure and temperature. Temperature is not constant anymore here, okay? If you look at the right-hand side, all of them are constants. Constant times constant divided by constant, we're going to get the same constant all the way. So you can call it K if you'd like. So what do we have? We have P over T all the time is going to be equal K. such that K is what? What is K? K is NR over TV. So what is the relation between pressure and time? What is this? Who can tell me what is this?
Direct proportional.
Directly proportional.
A perfect direct proportional. Good. C. Most people are familiar with Celsius or Fahrenheit units for temperature or both. Why can we not express temperature in these units when using the ideal gas law? Okay, let me copy this again. What is the ideal gas law? PV equals nRT. The question says, why T cannot be in Celsius or Fahrenheit? Any ideas? Let me ask you a question. The pressure.
Because I think it's because like only T has a unit and P, for example, it has a different unit. So it would be like a unit divided by a unit, like a different unit.
Yeah, but okay, it's a good idea, but still the T has a unit. But it's not Celsius, neither Fahrenheit.
Kelvin.
Go ahead. Okay, the pressure. The pressure is it takes positive value or negative value? The pressure, it's always what?
Positive.
Positive. What about the volume?
Positive.
Positive. Number of things, and can the number be negative? Number of the molecules, whatever you call
No.
it.
No.
It cannot be negative, right? So the R.
Yeah.
What is the R? It's a constant, right? And it's a positive. So these are positives. Positive, 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 positive. So the temperature is always positive. But what we know about the Fahrenheit and Celsius?
It can have negative temperatures.
Thank you very much. They can be negative. They can be negative. So because all of P, V, and R take positive or maybe zero positive values, T temperature is always positive. However, temperature in Celsius or Fahrenheit can be negative. So that's why we cannot write this in Fahrenheit and in Celsius. Okay, D. D. Suppose the volume of gas is tripled and the pressure halved. How does the temperature change? So the volume and the pressure. So we change this and this. We need to see the effect on the temperature. Again, let me write the relation first. PV over T equals N times R, right? Right? Why did I rewrite this? Okay, let me write this first. This is T here. Okay. We know that n is constant, r is constant, right? And the others, we need to see the effect of changing two, okay? The effect of changing two of them on the third one. So what I'm going to do, I'm going to write the variables in the left-hand side and keep the constant on the right-hand side. Okay? Now, whatever you have PVT, if you plug PVT in this relation, the answer is going to be constant as is, NR. It will never change. For example, if I give you now, if I give you now pressure 1, V1, T1, and I told you what is the relation between these guys, you're going to tell me P1 times V1 divided by T1 is equal N over R. If I give you another values for P2, V2, T2, and I'm asking you what is the relation, you're going to tell me again, it's the same thing. P2, V2 over T2 is always going to be N times R, which is constant. Each of them are constant. So that tells you the relation, these guys, they're always equal. So P1, V1 over T1 is always going to be equal to the P2, V2, T2, and is always going to be equal to the others. I mean, if I give you another pressure, another volume and temperature, if you multiply and divide them, they're going to be equals NR. And NR is fixed. Both of them are fixed, right? Do you understand what I'm saying?
Yes.
Good, thanks.
Yeah.
So what we're assuming now, we are assuming, okay, let's say the P2 equals half of P1, the pressure half. And we are assuming that the volume V2 is equal to 3 times V1. We tripled the volume. So what is going to be the effect on the temperature? I'm going to plug these guys here. Okay? So what's going to happen? So P1, V1, T1 is equal to, I'm going to replace P2 with half P1, sorry, times V2 will be replaced with 3V1 divided by T2, right? And I'm going to cancel because I can cancel P1 with P1, divide both sides by P1, divide both sides by V1, right? Multiply both sides by T1, T2, you get T2 equals T1 times 3 over 2. So what does it mean? It means T2 will be equal to this. This is the effect on the temperature. The temperature is going to be 1.5 of the temperature 1. Okay? Jacob is out or you are in? Okay. Okay? Question. Is it clear, everyone?
Yes.
Yeah.
Yes.
Very good. Let's move to the second question. 7.8. 7.8.
They didn't mute.
Okay. 5 woodchucks would chuck 8 pieces of wood in 2 hours. If a woodchuck would chuck wood, yeah, sure. How much wood would one woodchuck chuck if one woodchuck would chuck wood for 1 day? Okay, so we have 3 things actually, and we need to understand the relationship. Okay, the goal is when we solve these proportional questions and rate questions, we need to understand the relationship between the variables. Okay, this is the first thing. For example, it says 5 woodchuck. I'm gonna say WC. Okay, what they're doing, they cut 8 pieces of wood, 8W, okay, in 2 hours. 2 hours, okay? I'm gonna say this is the time. This is the time, okay? 2 hours. So this is the time. So we need to understand the relationship. So what we're gonna, the relationship between what? We have 3 things. We have woodchucks, wood pieces, and time, okay? So let's first say, okay, suppose, let me, again, we are trying to understand what's happening. If we keep this as is, 5 woodchucks, okay? And suppose I'm doubling this. I'm saying that, okay, this is 16. 5 woodchucks is going to do 16 watts. What is the effect this on the time? How many hours I'm gonna do this? What do you think?
4?
Yes, 4, because you have 5 woodchucks. They are doing 8 woods pieces, right? In 2 hours. If I'm keeping 5 woodchucks as they are, 5, but I want to get 16 woods, 16 pieces, sorry. In how many hours I'm going to do this? So the question is how many hours? How many hours? Or what is the time? The time is going to be 4 hours. The time, this is the time, okay? 5 hours. It's 5 hours. This 2 hours, okay? 2 hours. The time. Let's study another relation. So now, if I fix number of woodchucks and double the wood, we've seen the relationship with the time. That's perfect. Now, let's try to do what? Double the, for example, the woodchucks. Let's say if we have 10 woodchucks. Okay? Suppose we have 10, or let's say, no, hold on. Let's say I don't know the number. I don't know this number, and I want to make 16. And I want to have the 2 hours only. So how many woodchucks do I need?
10?
10, right? 10, right? So we need here, we need 10. We need 10 woodchuck. Okay. So what's happening actually? So let's summarize what's happening. We have woodchuck, we have wood, and we have the time. If this is constant, and we double this, for example, this must be doubled, right? Do you agree? If we keep the time constant,
Yeah.
if we keep the time constant and double one of them, the other one must be doubled, right? Do you agree?
Yes.
Okay, so the W, the wood pieces, is directly proportional with W, C, and T. Do you agree?
Yeah.
What is the relation between W and T and this one? It's direct relationship, right? If W, you divide it by T, you get WC, constant. Or T divided by W, you get constant. The same thing here, right? W divided by WC equals T, constant. Each of them, right? So the W has a direct proportionship with both of them. So the first thing we did is understanding the relationship between the three variables. We found that number of pieces, right? Number of pieces has a direct proportional with both variables, WC and T. What does this mean? What does this sentence mean? W, if you divide it by WC times T, this guy has to be constant all the time. This is the meaning of this sentence. Do you agree?
Yes.
Good. Now, if we back to question, the question give us, it says, if WC is 5, and if W is 8, and if the time is 2 hours, so from all of these guys, we can get that constant. We can find it. We can just plug these guys. So we have 5 over 8 times 2. This equals to K, the constant of proportionality. So K equals 5 over 10, which is half. So that tells me all the time W over WC times T must equals half. This is fixed, doesn't change. Whatever you give me W or WC, we can get the T, because the relation always give you half. W over WC times T is equal to half. So give me two of them, I give you the third.
Shouldn't it be 5 over 16?
Okay, now, yes, now we need to use this stuff to get the answer, right? What does the question ask us? To do what? How much wood? So the question says, find W, right? WC is given to us, which is 1, right? And what is the time?
1 day,
1 day is what?
24 hours.
24 hours. So we need to find W. W over 1 times 24 hours equals half. So W equals, which is what? 12 pieces. Do you agree? Do you agree or no? Is it clear?
Yeah.
Yes.
Yeah.
Good. Okay. Seven 7.9. One day Dale drove 100 miles at a constant rate, right? how far would he have traveled if he had doubled his speed and tripled the length of the time he drove? Again, okay, some students, they're gonna say, okay, we know the relation between the velocity and time and whatever the distance, but it's good to understand the relationship, right? So we need now to study the relationship. The distance, let's call it S. Okay, so he does 100 miles and constant speed or constant rate. So it's going to be rate is constant. His speed is constant, okay? And the time, you want to study the time. So let's say the time is t. It's just t, okay? The time is just t. The rate is r, constant, okay? So let's try to play with this and try to understand what's happening. Let's say the S is 200 miles. Okay? The distance is 200 miles. And the rate is constant. What's going to happen to the time? If you want to travel not just 100 miles, you want to travel 200 miles with a constant rate.
Multiply by 2.
The time would be double.
Yeah, the time would be double.
Perfect. Will be double, right? Good. Okay, what about if the miles is constant? Right? Double the time here, double the t, right? And the time is as is t. We did not change it.
Then the speed would have to be doubled. The rate.
Okay, this guy's gonna be doubled, right? So what do we have? The s, the distance, is directly proportional with the time. Do you agree? Yes?
Yes.
Yeah.
Also, the s is directly proportional with r, the rate, right? So here, from these two, because s is directly proportional with both, so s directly proportional with t and r. That tells us s over r times t is equal k, the constant of a proportionality. And actually, you will discover later this k is 1, has to be 1. Okay, this k has to be 1. This is going to be later, maybe. This is 1. But s over r times t is always equal constant, which is 1, k in this case. Okay, let's say it's k. So there's a direct proportional between the distance and the rate and the time, right? So it's constant, actually. So again, we're going to do the same thing as we did before. If I give you SRT, for example, if I said I give you S1, R1, T1, so S1 over R1 times T1 is going to be K all the time. If I give you S2, R2, T2, so you get the answer is going to be the same. S2 over R2 times T2 is going to be all the time K. So that means this ratio is fixed. So S1 over R1 times T1 is equal to the S2 R2 T2. So these are equal. In this problem, we are saying that the rate, if rate 2 is equal to the 2 rate 1, right? If we treble the speed, if we double the speed, double the rate, and if we double what or triple what? The time. So T2 is going to be equal to 3T1. The question is, how far would he have traveled? We need to get what do we call it? The distance, right? Okay. S1 is the first distance. The distance is given to us, 100 miles. S1 is 100 miles. Right? R1, T1 equals S2, we don't know it. R2 is 2R1. T2 is 3T1. Okay. So what do we do? This cancels with this. This cancels with this. Multiply both sides by R1, T1. Multiply both sides. If you just want to understand what's happening, I multiplied both sides by R1, T1. Okay? So they canceled. So what do we get? We get 100 equals S2 over 6. So S2, the second distance, or the distance is 600 miles. He drove 100 miles at constant rate. How far would he have traveled if he had doubled his speed and tripled the length of the time he drove? This is doubled, this is tripled. First, we understood the relationship. The relationship is direct proportional. S and R and T, okay? S is directly proportional with R and T. Okay, questions? Is it clear? Questions? Any questions? No?
No.
Okay, rate problems. Prima has a dentist appointment today at 11 o'clock. Usually she drives 45 minutes per hour and it takes her 30 minutes to get to the dentist from her house. So let me write the number of the question. The appointment is at 11. Important keyword. She drives. This is the rate. And this is the time, right? If she leaves 10:30, how
I got,
fast?
for this problem, I got 60 miles per hour.
Okay, would you like me to do it? You're the only one who got it. Can you do it, everyone? Or let me find it. I don't know. Let's check. 60 miles. So how
Yeah.
fast? We need to get how fast should she drive to get the dentist
Yeah,
office on
60
time?
miles per hour. 60 miles per hour.
60 miles per hour. Okay. Any any other student who found this or no? No? Okay. Let's try to do it together, okay? So the rate is 45 miles per hour, okay? The time is 40 minutes, right? So first of all, let's find the distance. So let's find the distance, and we already discovered the relationship between the three variables, okay? So we said there's a relationship between S, R, and T, and I told you let's K to be 1, okay? So the distance is from her house to the dentist is S equals, the rate is 45 miles per 1 hour, right? Times, the time is 40 minutes, that doesn't work, right? So we have to change this into minutes or hours. So let me change this to the minutes here. 1 hour, let's say 60 minutes. Okay. So what is the S? You multiply them, you get the answer, which is 30 miles. What is S? S is the distance between her house to the dentist, right? So S is 30 minutes. Now she leaves her house at 10:30. She must be there at 11. So what is the time here? What is the time that she has?
30 minutes.
30 minutes. So she has 30 minutes. She has 30 miles. Let's find the rate, okay? We know that S equals R times T. So the rate is equal to the S over T, right? And we have 30 miles divided by 30 minutes, which is half an hour. And as Krish said, it's 30 over half, which is 60. 60 miles per hour. First of all, we knew the distance between her house to the, because this is constant, fixed, doesn't change. Then we knew the time. Then we got the rate. Right? Okay. Questions? Seven point 10 or 11. Jack drove 30 miles per hour to work. As soon as he got to work, he remembered that he forgot to feed his dogs. So I spit back home driving 45 minutes per hour. So different rates, right? What was the average speed during his round trip to work and back to home? First of all, the average speed, it's important to know. The average speed is equal to the total distance. Do not ever add the two rates and divide by 2 here. No. The average is the total distance over the total time. Okay. So there's the first, okay, he has 2 trips actually. He went to the job, to the work. There's the first, the first trip, the second trip when he got back. So the first trip, there's an S, distance. S equals, let's say S1 equals R1 times T1, right? And S2 equals R2 T2, right? Note that S1 equals S2. Do you agree? Let's call it X miles, right? So what is the total distance? The total distance is S1 plus S2, which is X plus X, which is 2X, right? What is the first time? Time 1, T1 equals S1 over R1. S1 is X, and R1 is the first rate. What is the rate? Okay, the first rate, R1 equals 30 mile per hour. R2, when he get back to home, 45 mile per hour, right? So this is 30. What is T2? Second time. Second time is the S2, sorry, over R2. S2 is X over R2, which is 45 miles per hour. Do you agree?
Yeah.
Good. So what is the, now we have everything actually. What is the, what do we need? The average. The average speed equals total distance over total time. Total distance, we got it already, which is 2x divided by total time. Total time is the first time plus the second time. T1 plus T2. But I don't want to write this in terms of T1, T2 because we need to have only one variable, which is X. So let me simplify. This one is equal to 2x over X over 30 plus X over 45. Do you agree? And this is the total time. So let me get a common denominator there. So we have 2x divided by this guy. Do you agree? Equals 2x divided by, if you multiply by 3 by 2, you got 95x. Right? Then we have 2x divide becomes multiplication, 90 over 5x equals, we got 90 times 2 divided by, we have 18 times 2, 36. 36 mile per hour. Do you agree? Any question? Is it clear?
Yeah.
Yeah.
Okay. So as I said, first of all, we found the total distance, and the distance is, you know, constant because why? Because this is his home. This is his work. He went here, then he got back again. So the distance is fixed. The rate is different. Because the rate is different, the time is going to be different, right? Okay. .12. Pippin and Sam are painting a fence. They're painting what? A fence. Sam could paint the whole fence alone in 12 hours. Pippin could paint the whole fence alone in 8 hours. Sam starts painting at 1 p.m. and Pippin joins him at 3 p.m. At what time do they finish? So first of all, this is kind of job is happening here, okay? Okay. So let me start by Sam. Sam, he can paint one fence, one fence, right? This is the job. I'm gonna call it the job, okay? One fence, this is the time, in 2 hours. 12 hours, sorry, 12 hours, right? And Sam's already started at 1. Okay? Now, Pippin, he can do the same job, one fence, painting the fence, in how many hours? In 8 hours, right? Pippin starts painting. What time? 3 o'clock. Do you agree? Okay, now the first thing I would like to study the relationship between both of them. Okay, we need to study the relationship between both of them. So we have job and time, right? What is the relation between the job, one fence, and the time, 12 hours? So he can finish one fence, paint one fence in 12 hours. What is the relation? Is it direct or inverse? How do you know? He can paint one fence in 12 hours. Just ask yourself one question. If for example, you have the job, half fence, how long is gonna take with him?
6 hours.
6 hours.
6 hours. So who can tell me what is the relation? Is it direct or inverse?
Direct.
Direct. Perfect. This is important. So there's a direct relationship. So I'm gonna call this one JS, job. The job with Sam. First of all, there is a direct relationship, J and T. J divided by T is equal to K, right? JS, J Sams, T Sams, okay? So this is a direct relationship. For example, for one fence, 12 hours is the job, K. K is the rate, actually. Do you agree? K plays the role of the rate here. The rate, he can do one fence in 12 hours. This is fixed relation, right? So K is 1/12. Let's say fence per, okay, or 1/12 of the fence per hour, we can say, right? So we can say that, okay, JS TS equals 1/12 all the time. This is the relation for Sam's, okay? Right? Let's think about this. Sam already started 1 o'clock, right? Let's first understand how much of the fence that Sam's has already painted until 3 o'clock. So from 1 o'clock to 3 o'clock, what is the time?
2 hours.
Excellent. So from 1 p.m. to 3 p.m., we have 2 hours. This is the time. So if I go back to this relation, the job of Sam's over time, which is 2 equals 1 over 12. So that tells me job of Sam's, he's done 2 times 1 over 12, which is 1 over 6 of the wall, of the fence, sorry. So from 1 o'clock to 2 o'clock to 3 o'clock already, Sam has finished 6 of the fence, painting 6 of the fence. So what is the job has left? How much? How much? How much is left? Who can tell me how much is left?
5/6 of the
5/6 of the fence. He has finished 1/6 already of the fence before Pippin joins him. Do you agree? So when Pippin joins him, okay, they have to complete the job. So the job, Sam's job plus Pippin's job has to be equal 5 over 6 of the wall, of the fence, sorry. Right? Do you agree? Sam's
Yep.
job is JS plus JP equals 5 over 6. Okay, we know this. Look at this. We know this guy. We know that J over T equals 1 over 12, right? We know that JS equals TS times 1 over 12. Also, we know JP equals TP times 1 over what? 8 hours. This is for Pippin, right? His rate is 8 hours, right? Is one fence the whole job for 8 hours. Do you agree? Do you agree about these two statements? Yes or no?
Yeah.
Yes. Good. What is the relation now between TS and TP? They have to be equal. So I'm going to call them T. Why? Because they're going to finish at the same time, right? At what time they will finish, both of them. So TS and TP is equal. They're equal. They're equal to each other. So I'm going to call them T, the time, because we're looking for this time, when they're going to finish, both of them. So let me go back to this relation now. The job has done, or the job is going to be done by Sam. The job that is going to be done by Pippin, if we add them, they have to finish 5 of the 6 of the fence, right? Okay. So what is JS? JS is T times 1 over 12 plus. What is JP? JP is T times 1 over 8. This equals 5 over 6. Do you agree? Let me quickly repeat, please. We have one job. Has to be done by Sam. Sam is can finish the job in 12 hours and Pippin can finish that job is in 8 hours. First of all, we understood the relationship. We need to understand, is it direct relation or inverse relation? So that's why we took examples. We said, okay, what half of the fence? What's going to happen with the time? And so on. After that, we found that the relation is going to be direct relationship. Then we found the constant of a proportionality, right? Then we know that Js equal over Ts equals 1 over 12. At the same time, you can tell me J Pippin over T Pippin equals 1 over 8. Same thing. But first of all, we need to know exactly when they start together, what's going to happen. Because the first guy started 2 hours earlier. So we need to know how much he has finished of the wall. So we calculated this. We found that he has finished 1 over 6 of the wall. What is left? 5 over 6 of the wall. This is the job. This is the J. So this J is Sam's job and Pippin's job together. Js plus Jp equals 5 over 6. What is Js? Is the time times 1 over 12, and this is time over 1 times 1 over 8. Because they have to finish at the same time, so these are equal. Right? Now we solve this equation. Multiply both sides by what? 24. What do we get? We get 2t plus 3t equals 4, 5. So 5t equals 20, right? So t equals what? 4 hours. So from 3 p.m., 4 hours, 7 p.m. So they will finish 7 p.m. Right? Is it clear?
Yeah.
Questions? Okay, good. Okay. Flo and Carl each must read a 500-page book. This is 7:13.
Wait, who's Ho?
Let's say Flo. Flo, okay? Flo reads 1 page every minute, right? So again, number of pages, 500 page, right? And there's a rate, this is the rate problem, right? So Flo reads 1 page every 1 minute, Carl reads 1 page every 50 seconds. Flo starts reading at 1 and Carl starts reading 1:30. When will Carl catch up to her? Same thing, actually. So let's find first of all he does 1 page every 1 minute. And Carl does 1 page every what? 50 seconds, or this is equal 5 over 6 of the minutes. right? Because 50 over 60, right? Which is 5 over 6 of the minute. Every 5/6 of the minute. This is Carl. And Flo already starts already doing this earlier, which is, so the rate, so there's again, we need to get the relationship. There's job here. The job of Flo over the time is going to be equal K, which is the rate in this case. So K is 1 over 1, which is 1. 1 page per minute. Right? But Flo started already earlier, so we need to know how many pages she has done at the beginning. We have 30 minutes there, right? So from 1 to 1:30, the time is 30 minutes. So how many pages she has finished? Equals time times K, which is 1, right? So this is 30 minute times 1 page per minute, right? Per minute. So minutes cancels with minutes. So we have 30 pages, right? Do you agree? Okay. Now, after, let's say, after X minutes, now we are talking about 1:30. They both will, one will continue, the other one is going to start from scratch, okay? After X minutes, the number of pages read by Flo JF equals X minute times X. Let me write the formula. We know that TF times 1, which is K, so which is X times 1, X pages. So after X minutes, we don't know how many minutes, so the job is going to be X pages. Same thing, after X minutes, number of pages completed or read by Carl is going to be JC, let's say. What is we said 5 over 6, right? 5 over 6 times X. Because, let me go back here. This one, look at this. JC, right? Over TC equals the rate, right? Which is 5 over 6. Sorry, this is 1 page. 6 over 5. Right? So this is 6 over 5 here. Right? Do you agree or no?
Yeah.
Okay. Because the rate is 6 over 5. times x. So we have number of pages after this time, number of pages after this time, okay? So the total pages already done 30 pages, right? Right? These are pages. Flew done already 30 pages of the first 30 minutes. Then it's going to be another X pages. These guys have to be equal. In other words, 30 pages plus the job of Flew after 130 is equal. We need it to be equal to the J Carl. So these are the same actually. 30 pages plus X pages equals 6/5X. These are the total number of pages actually, right? That both are going to be the same because we need these number to be the same, equal. Why? Because this is the whole question about. We need these guys to be equal because the question says, when will Carl catch up to her? When they're going to be the same? When number of pages they're going to be the same? This is the question actually. Okay. Okay. Then we solve this. To get the time. Okay. This is X pages. Okay. The time X. The time 30 minutes as well. Okay. So these are 30 equals 50 minutes. Because we assume that X is number of the minutes. So after 150 minutes, which is 2:30, 2 hours, 30 minutes. So 1:30, they started together. After 2 hours, 30 minutes, we're gonna go where? 4 o'clock p.m. So he's gonna catch up at 4 o'clock. Do you agree?
Yeah. Yeah.
Good. Okay. Seven point 14. Barry owns a house on a river. Okay. The river flows at 3 miles per hour. Barry decides to start rowing down streams with the current at noon. This is important. At noon, the first piece of information, he goes downstream with the current. So let's say this is his place. This is the river. Oh, sorry, this is the not the river. This is the place that he's going there. I don't know. Let's say that he's going here somewhere. This is the river, okay? And he's going downstream from his house. So this is downstream. This is the current. right? At noon. So this is 12. The rate of the river is 3 miles per hour. He wants to return his house at 5. So the total time is 5 hours. You want to go somewhere and get back in 5 hours, okay? At what time should Barry turn around and row home if he normally rows 5 miles per hour? So the rate of Barry is 5 miles per hour in water that has no current. Okay, we have two things here actually. Okay, so if you're rowing with the stream or against the stream, so we have two rates for Barry. So Barry, okay, the rate of Barry with the current, the rate of him is going to be 5 miles plus 3 miles per hour. So the rate is going to be 8 miles per hour. This is important. He's rowing with the stream. His rate is 5 plus 3, the current, so it's added to him. They're both at the same direction. He's going with the same current direction, so it's going to be 8. But when he go back, there's a resistance, right? So the rate, his rate, let me repeat this because, okay, the rate of him against the current, RA, I'm going to call it RA, is 5 miles per hour minus 3 miles per hour, which is 2 miles per hour. Do you agree? Right? So we know now two things. We have his rate when he goes with the stream, right? With the current and against the current. The second thing, we know the total time. Time when he goes with the current plus time against the current is equal 5 hours. This is the second piece of information we know. The third piece of information we know, the distance. The distance when he goes down with the current, it should be equal to the distance when he go back. Because actually, if you actually travel from here to here, you're gonna get back to the same distance, right? So it's gonna be the same distance, right? Okay. So when the distance are equal, let's call it the distance. I said S. I call it S before S. So the distance SW equals SA. What is SW? SW is the rate. W times TW equals, what is SA? SA is the rate A times TA. But RW, we know it. His rate with the stream, which is 8 times T. What is RW? It's RA is 2 times TA. What does tell me? What does this tell me? Divide by 2 by 2. So the time against the stream is equal to the 4 times TW. And we know this other equation. So I'm going to use these guys. Okay? The total time is 5 hours. When he go with the stream or with the current or against the current, you just plug these guys. You solve it as a system of linear equations. So it's clear that one of them is going to be 1, the other one's 4. So plug this here. What do we get? TW plus 4TW equals 5 hours. 5TW equals 5 hours. So the time when he goes with the stream is equal to 1 hour. And the time when he go against the stream, when he go back to his home, is 4 hours. He started at noon. It took him 1 hour, right, to reach to somewhere. Then 4 hours to go back because the rate is much lower than the first one. The first one was 8 miles per hour. The second one is just 2 miles per hour, right? Questions? Questions? Is it clear?
Yes.
Okay. 2 trains each moving 20 miles per hour. Anyway. Seven point 7.15. 2 trains moving 20 miles per hour towards each other are initially 60 miles apart. So we have one train here, train A. Let's say this is train A, train B here. Okay, so they are moving the rate. So the rate okay, the rate train A, TA, I'm gonna call it TA. No, train A, sorry, train A. Train A, train B. They are 60 miles apart. The rate of train A is 20 miles per hour. The rate of train B is the same thing, 20 miles per hour, correct? A B starts at the front of one train, flies to the other one, then back to the first train, and so on. If the B always flies at 30 minutes per hour, so the rate of the B is 30 miles per hour. How far does the B fly? So we need to get the distance, S of the B. We don't know it. Before the train collide. The train collides. Okay, we need to get the time. Actually, look, we have this relation here. Sorry. We have the SB equals to the RB times TB, right? The rate of the B, we know it, 30 miles per hour. We need to get the distance, that the total distance that she has done, the B. But we need to get the time. What do we know about the time? The time when they collide, when the trains collide. It's clear that the trains will collide when distance equals distance. The second one, S, let me call it S as S of the train A, S of the train A is equal to the S of the train B. Do you agree? They're gonna collide in the middle here because they have the same speed, the same rate. It's 60 miles, so they're gonna collide in the middle. So it's 30. When this is 30 miles, right? So what is the time? The time of A is equal to the time of B. which equals to 30 minutes divided by 20 mile per hour, which is 1.5 hours. Do you agree? So after 1.5 hours, they're gonna collide. Is it clear?
Yeah.
So we got the time. We got the time. So what is the S for B? S for B is R for B times T for B, the B, right? Her rate is 30 miles per hour. The time is 1.5 hour. So 30 times 1.5 is 45 miles, which is